In this video, we're going to take a look at some other things that structures can do. The example that I'm using here is one that I've used in previous videos. It is the student record example, so you'll find it familiar. And this one has the hierarchical structure date embedded within it. And it also has the functions that I've used earlier, enter data by value, by reference, and so on. And we have Alice and Bob as we did before. So I want to start with this program, which is a complete program. You can compile it and run it. It works just fine. So it is complete. But I want to look at something very special that you can do with structures. This would be really good if you could, if you get this example and then go ahead and do what I'm doing on your computer, then it would be advantageous, I believe. The first thing I want to do is I want to take this word struct and I want to replace it with something that you might have seen or heard about, class. Just going to call it a class. There are no red underlines anywhere. The other thing I want to do is inside this structure, I want to type the word public and add a colon afterwards. Now, just making those two very small changes will the program compile and run. I'm going to put click the build option. And it succeeded. There are no errors. If I now run the program, what will I get? Well, the program does run. We have the black window that pops up. And we have the subroutine is called so that we can enter the data for Alice. So the program works. And I will not do this for everything that I'm going through, but let's go and type in the data this time. I'm typing data. I want Alice. I'll type in her first and last name. Date of birth 2/23/2000. Grade point average, say that's 3.5. Exam average 88. And the homework average says 93. So when I type in all this information, then the compute grade function is called. That gives Alice the grade, and then her complete record is output with our print record function. So it works just fine. And we also have the data for Bob. Let's go ahead and do Bob too. Bob Jones, date of birth 6/25/1999, grade point average 3.4, exam average 87, and homework average 91. So we compute his grade and then we print out his complete record. So this program gives us exactly the same output and behaves exactly the same as it did when this was a structure and we didn't have public in here. So the terminology is changing just a little bit. I know you've heard of classes, and classes are related to objects, and that's what I'm building up to here. We do have to have public, and that's because with a class you can designate members to be either public or private. And we don't have any private members. At a very minimum, you have to have public members. That's why I had to put that here. But you can also add private if you want to. So I can do private, colon, and then I can put some variables here, int x, y, z, for example. So with a class, you can have a public part, and you can also have a private part. So that will come later. These things are called hidden variables. They can only be used in a very special way. Okay, spell that correctly. All right, so this then shows you that a struct is very, very similar to a class. Now, we ran this and we did see that it worked. I didn't do it after these private variables, so I can do that just to show you that it does compile and it does run. So here's the output, but I'm not going to type in the data again. This just shows you the program does work. There's something else now that we can do. And since we aren't going to be looking at these private areas of this class right now, we'll get to that later on, and in a future video, I'm going to take those out. I don't want to overcomplicate things. Let's do something almost magical. Open up some space below all of these members, and then get these two functions, the enter data by value and enter data by reference, and let's just cut them from here, and let's paste them inside the structure, or in this case, inside the class, now that we've made this a class. So, in addition to having ordinary variables, this class now has member functions. Okay? These are member functions. So now a class can have variables and it can have functions. If I try to compile and run the program by doing this, however, it will not work. There's some additional stuff we have to do. So I will go ahead and show you that it will not compile now. There are many errors down here that you can see. So if we have incorporated these two functions to be part of this class student record, then we have to do some maintenance on these functions. It's not very complicated. Here's what we have to do. When we go down to the enter data by value function, we have to do something that binds this function to that class. So it doesn't change the type. The type is still student record. The name is still this, but we have to bind that name to the class. And the class is a student record. So we type student underscore record, but then we have to type 2 colons. So this thing is called a scope resolution operator, and by adding it in front of the name of the function, we are binding this function to that class. We need to do that for the other function we're using, so I will copy and paste this portion. Copy. The other function that we put into the class is enter data by reference. It has to be bound here as well. So now it is a type void, and its name is still enter data by reference, but it is now bound to the class by using this student record double colon notation. That's the first extra thing we have to do. We have to do the binding of the functions. When we scroll back up to the main program now, you'll see we do have some red underlined areas. So if we are calling enter data by value to give Alice some data, then something's wrong here. The thing is, when we are using Alice and Bob, let me just briefly type this in. Now, if we wanted to, that's okay, if we wanted to access a element of either Alice or Bob, we used Alice dot, and then, it's a lowercase l, we used Alice and dot, and then whatever field we wanted, like exam. So we used the dot notation in order to access that member of Alice. Now we have member functions. We'll access those functions using the same technique, the dot notation. So we have to do Alice dot, over here, Alice dot enter data by value. All right, so enter data by value, that is part of this student record Alice, okay, and also for Bob. So now if we want to call that function, then we have to indicate what class it belongs to, right? Alice and Bob belong to the class student record, and enter data by value belongs to the class student record. So we have to use this dot notation to access that member function. Same thing down here for Bob. We can't just call this function directly. We have to use the dot notation, where Bob, now he is a student record type, and as part of that record, now there are these two functions. So this is an expansion then. So now a class, it has ordinary variables and it can have member functions. Okay, now that has eliminated all of the red underlines, everything now is actually going to work. Let's compile and run the program. We'll build it. It did build. I'll run it. And our output window comes up. And you can see, enter student data for Alice. I'll do Alice and then we'll stop. We won't do Bob. This will show you that the program is working. Say 3.2. Exam average, say 89, and then the homework 91. So it worked, right? So here we have the data record for Alice. We print it out, so the program works perfectly fine. The output looks the same as it did before. Let's review one more time. If you have a class, then you can include within that class functions. So these two functions now are member functions of the class student record. These other two functions, print record, compute grade, those are still just regular, ordinary, garden variety functions you can call in the usual way. Now that we have bound these functions to this class, we have to do a little editing. By binding, we have to precede whatever the function is by the name of the class followed by the double colon. And if we want to reference that function, we have to use the dot notation to do that. Wow, pretty amazing, huh? Well, we quickly and easily converted a struct into a class. There are some terminology changes now. Instead of saying we have, and actually I've already changed the comment here. Instead of saying we have variables of a type, now these things, Alice and Bob, they are objects of a class. So we can speak of an object-oriented term here, object-oriented programming. So now Alice and Bob are technically objects of the class student record. They still behave like variables as we saw earlier, but technically they're called objects now. One final thing before we close this program and stop this video. Let's go back and look at the class. Okay, so now we have the internal parts of this class as shown here. Let's take the word class and let's turn it back into a struct. Struct student record. I don't see red underscores. If I build it, then it does compile. If I run it, guess what? It works equally well. So perhaps there's been a little bit of magic, or we've been just giving you the wrong terminology up to this point. But as it turns out, a struct and a class are the same thing. There are some tiny little differences that you can look up, but essentially we've been calling this thing a struct all along, whereas we could have equally well called it a class. So a struct can also have a public area. It can contain member functions. You can bind them the way we've done down here, and it still works just fine. So this is kind of a interesting little exercise with structures and classes. So at this point, we are going to go ahead and close out this video.